Yes, good morning, everyone.
Good morning, sir.
Yeah,
Good
good
morning,
morning.
sir.
Good morning, sir.
Good morning, sir.
Good
Arey,
morning, sir.
your regular classes starts from 10:30. Your regular classes?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, okay. Uh, actually, I was there as a scrutiny member for non-teaching staff recruitment. That means very recently NIT Raipur has conducted one written examination for non-teaching post for superintendent or otherwise lab assistant, technical assistant, okay, a lab attender, senior technician. For these type of post, one written exam was conducted. So I have been allotted to correct the OMR sheets. Okay. So that is since long 3 months onwards that work is going on. Now we are about to wind up the things and about to release the results. So okay, director sir has okay given instructions to wind up at the earliest. So I may be busy whole day for okay some days around 1 week or 2 weeks to wind up that. Then I thought to skip the class. I'll take it next week, Monday we may take. But I thought, no, no, no. Okay, anyhow, okay, at least 1 hour I have to manage. So only 51 candidates have joined. Can I start this class? Can I start? Is it okay?
Yes, sir.
Hmm. Tomorrow also I may take like this only around 9 o'clock or otherwise 8:30, 8:40. So please inform to everyone. Okay? Okay, na? Are you ready?
Okay, sir.
For tomorrow also, okay, almost for the same time. Are you ready?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. See, just once again, quick revision. See, in my class, every time quick revision would be there, almost in every class. Yes, applied chemistry, how many units are there? Speak up, speak out.
Four.
4 units. Technology
Four.
of water,
Fuel combustion engine.
fuel
Fuel
combustion
combustion and
instrument,
cement.
uh,
Corrosion and phase rule.
corrosion and phase rule, polymers and lubricants. So in the technology of water, what is hardness and its determination by using EDTA method that was over. Metal EDTA complex colorless, metal EBT wine red color, disodium salt of EDTA we are using. At the end point blue color, that blue color is due to free EBT indicator. We are using buffer solution, that is basic buffer solution. We have to maintain the basic pH 8 to 10 because at the basic pH the complexes are stable. This is about hardness. Now in the previous class, alkalinity was discussed. See, in the alkalinity, what is the alkalinity normally? The increased hydroxide ion concentration that leads to alkalinity or otherwise alkaline water. See, normally what happen, okay, because of hydroxide or carbonate ion or bicarbonate ion, these three ions are the responsible for the alkalinity. If these three ions are there in the water, then that water is alkaline. Alkaline means normally pH is more than 10. Normally, or otherwise above 7. That is alkaline. So, as the water is alkaline nature, to determine the alkalinity, it should be titrated against a standard acid. This is simple neutralization titration. So when it is titrated, so the definition was given like this. That yes, speak out. What is the definition of alkalinity? The capacity of water to neutralize the
Acidity.
acid.
Acid.
Okay, or otherwise the ability of water sample to neutralize the acid. See, ability of the water sample means the ions which are present in the water sample, they may react with acid substances. So they are converted into normal neutral products like H2O, carbonate ions or bicarbonate ions. Yes, please mute Neil 64 rule number. Please mute your mic. Uh, now is it okay? Is it visible?
Yes, sir.
Yes, sir.
Uh, See, once again, quick revision. What is alkalinity? The capacity of water to neutralize the acid. Which ions are causing the alkalinity? Hydroxide, carbonate, bicarbonate. Normally, there are two types. Hydroxide and carbonate ions are caustic alkalinity, and bicarbonate ions, HCO3 minus ions, are the temporary alkalinity or otherwise bicarbonate alkalinity. So here, as the capacity of water to neutralize the acid, so during the titration, what type of chemical reactions are taking place? That hydroxide H plus, that is converted to H2O, carbonate ions, bicarbonate ions H2O and CO2. These type of chemical reactions are taking place. And at the same time, with the help of phenolphthalein indicator, we can able to determine the hydroxide and half of the carbonate. Half of the carbonate, understood?
Yes, sir.
Please. Huh?
Yes, sir.
Yes, sir.
Yes, with the help of methyl orange indicator, we can able to determine the total alkalinity. My conclusion is, see here it was written, with the help of phenolphthalein indicator, we can able to determine the hydroxide ion concentration and bicarbonate ion concentration. And with the help of methyl orange indicator, we can able to determine the total alkalinity. What are the possible combinations? There are 5 possible combinations are there. Either the water may be alkaline due to hydroxide ions alone, carbonate ions alone, bicarbonate ions alone, hydroxide carbonate together, or carbonate bicarbonate together. These are the 5 possible combinations are there. The next one is, yes, see here one table is there. This table, okay, represents that. Some students are joining. 1 minute. So here, this table indicates that what it is indicating that. See here, these are the titration results. Okay, titration results. What are the titration results? What you are doing? What is the titration? Yes, the procedure was given. Okay, very nicely it was explained in the last class. But once again, I am explaining what is the procedure. Okay, this is the observation table. Okay, serial number 1, volume of water sample 20. That means pipette out 20 ml of water sample. Then initial reading is 0. That means burette, here acid is there, acid substance, because we are titrating with acid. Then burette, here conical flask, we are taking alkaline water of 20 ml. Then okay, add phenolphthalein indicator. Here I said why we are adding phenolphthalein indicator at first, because phenolphthalein indicator at basic pH it works properly. It works only basic pH. Hence it is showing pink color as it is basic medium. So you add 1 or 2 drops of phenolphthalein indicator, the solution turns to pink color. Then here, when the solution turns to pink color, okay, start the titration. Start the titration. When the solution turns to pink color to colorless, note down the end point, that is the phenolphthalein end point, because this end point you are achieving with the help of phenolphthalein. Then to the same solution, okay, to the same solution. Normally in our lab what we are doing, after completion of actually after addition of one indicator and completion of one slot, simply we are okay, decanting the solution. We are okay, removing the solution, we are washing and we are going for another slot. But here you have to continue the same titration. To the same conical flask, add one or two drops of methyl orange indicator, the solution turns to light yellow color. that light yellow color solution titrated against, okay, acid which is present in the burette, continue from same titration. So for example, here you got 10, then 10 burette reading is 10 or end point is 10, then from 10 onwards you continue the titration. Don't make it 0 because already initially it is 0, phenolphthalein end point 10, then 10 onwards you continue here. Then let us assume that you got 20 methyl orange end point. That means what is the end point? End point is pinkish red color. When the solution turns to pinkish red color, stop the titration, note down the end point, that is a methyl orange end point. Now, so here that methyl orange end point. Then after that, stop the titration. Just remove that solution. Wash the conical flask. Then you go for another slot of titration. That means again 20 ml. Then make it 0 burette. Then again continue the titration. That means add phenolphthalein, pinkish red. Then end point colorless. Note down the reading here. Then again add methyl orange indicator. Then light yellow color. Then continue the titration. That is going to turn pinkish red color. When it is appears, that is a methyl orange end point. That means alkalinity up to methyl orange end point. Note down the reading. That end point. Then okay, go for calculation. What is the calculation? Okay, here you are getting the concordant reading of phenolphthalein. You are getting the concordant reading of methyl orange. See here, what is the calculation? The calculation is N1V1 is equal to N2V2. As per the law of equivalence, let us assume that N1V1 is the water sample, N2V2 is the acid sample. Okay, that means the solution which is present in the conical burette. Now calculate either water normality. That means either N1 or otherwise N2. Let us assume that N2 is the water sample, N2V2 water sample, N1V1 is the acid sample. See, the normality of acid sample is provided. That means that is the known concentration, N by 100 or other by N by 50, that would be given. Then substitute V1 value here, alkalinity up to phenolphthalein end point, first one. Phenolphthalein end point to V1 means phenolphthalein concordant reading. So N1 already given, V1 concordant reading of phenolphthalein, N2 question mark, V2 20 ml. Calculate the N2. Then after that, calculate the strength. Strength equals to normality of water sample. That means here N2 you got, that normality you substitute here. Then equivalent weight of calcium carbonate, that should be multiplied with 1000 in order to get in ppm or otherwise in milligram per liter. Like this, you calculate the phenolphthalein end point. Then similarly, alkalinity up to methyl orange end point. Then N3V3 is equal to N4V4. Let us assume that N3V3 is the water sample, N4V4 is the acid sample. Okay, N3 question mark, V3 20 ml water sample, N4 acid sample N by 100. Then V4, that is the volume of acid consumed by using methyl orange indicator, methyl orange concordant reading. So calculate the normality of water sample by using methyl orange indicator. Then calculate the strength. Strength is equals to normality of water sample into equivalent weight of calcium carbonate into 1000. So you calculate the both indicators alkalinity. That means phenolphthalein alkalinity up to phenolphthalein end point. Strength you are getting P is equal to, say, let us assume that P is equal to 100. Then methyl orange end point, methyl alkalinity up to methyl orange end point, that M you are getting, let us assume that 200. Then you have to compare what is the relation between P and M. With the help of that, you can able to determine what type of ions may be present in the water sample by knowing the strength of phenolphthalein and methyl orange. Okay?
Sir, excuse me, sir. Some students are waiting for entry, sir. Please allow him.
Okay.
Yes.
Yes. Rohit Kumar I added. Yes, anybody else? I think only one student I added. So here you go for the titration results. That means in your examination or otherwise during the practical, the object is like this. What is that object? The strength of HCl solution is N by 100. Then calculate the alkalinity of calculate the type and extent of alkalinity of water sample with the help of phenolphthalein and methyl orange indicator. Once again, what is the object? Once again, I am saying, what is our aim in our lab? The aim is like this. Okay, determine the type and the extent of alkalinity of water sample with the help of phenolphthalein and methyl orange indicator, and the strength of HCl solution is N by 100. This is our object. That means HCl strength was given, that is the N by 100. What we have to do? We have to calculate what type. Type means whether that is caustic alkalinity or temporary alkalinity. Caustic alkalinity means either hydroxide or carbonate, or otherwise temporary means if bicarbonate. If both are present, yes, the water is caustic and as well as temporary alkalinity, alkaline in nature. And the ions are okay, hydroxide and carbonate. Extent of those ions means, extent means what is the quantity of that? That means yes, phenolphthalein strength is this much. Phenolphthalein means hydroxide is this much, carbonate is this much. How we are calculating that? See, let us assume that you go through here. See, if P is equal to 0, that means you pipette out 20 ml of alkaline water sample, then add 1 or 2 drops of phenolphthalein indicator, but the solution does not give any coloration with phenolphthalein indicator. That means hydroxide and carbonate ions are totally absent. So here 0, 0. So, okay, you would be getting only bicarbonate ions. So whatever the strength you are getting, that means alkalinity up to methyl orange endpoint you are calculating. So that strength is nothing but bicarbonate ion strength. अरे समझ में आ गया कि नहीं आ गया?
Yes,
Yes,
sir.
sir.
हाँ. See, what is our aim is we have to calculate the type and as well as extent of that alkalinity. Type means yes, bicarbonate ions are there. Yeah, okay. At the end, you can write yes, the water is okay, temporary alkaline in nature. This is the type. Then what is the extent of that alkalinity? That means bicarbonate ion is there. So bicarbonate ion is equals to, if you are getting methyl orange alkalinity up to methyl orange endpoint, then if it is 200, write down the 200. If it is 100, write down the 100. Then if P is equal to M, if P is equal to M, okay, what does it mean? Somebody sent one. Okay. P is equal to
Excuse me, sir.
Huh?
Sir, some students are still trying to join.
Okay, okay, admitted. Okay, now they are activated. I think now they wake up. Huh? Hmm. So that means if P is equal to M, what does it mean? P is equal to M means pipette out 20 ml of water sample, add phenolphthalein indicator, the solution turns to pink color, titrate against standard acid. When the solution turns to colorless, stop the titration. Now, okay, now you add methyl orange indicator, but the solution does not give any coloration. So that indicates that okay, hydrocarbonate and bicarbonate ions are absent. Or otherwise, see how we are going to calculate, how we are going to exactly okay certify these. Okay, even with the colors. Okay, sometimes if you are getting doubt, simply you do the calculation. Okay, you do the calculation. If okay, phenolphthalein alkalinity up to phenolphthalein endpoint. If you are getting okay, if you are getting 100, then at the same time alkalinity up to methyl orange endpoint also 100. That indicates that P is equal to M. Then if P is equal to half M, if P is equal to half M, if P is equal to, if you got P is equal to 100 and M is equal to 200, what is the relation between P and M? Hello?
Sir, P equal to
P
half
is
M.
equals to
P is
half
equal to
M.
half M. Yes. If P is equal to half M, which type of ions may present? Only carbonate ions may present. Remember this. If carbonate ions may present, then what is the strength of carbonate ion? 2 into P. That means 2
2P.
into 100. So 200. So carbonate ion strength is 200. अरे समझ में आ रहा है कि नहीं आ रहा है?
Yes, sir.
Yes, sir.
So see, blindly you remember this table. Alkalinity, everything would be in your mind. If P is equal to 0, bicarbonate ions may present. If P is equal to M, hydroxide ions may present. If P is equal to half M, carbonate ions may present. The carbonate ion strength is 2P. Okay. Then similarly, P greater than half M. P greater than half M means if P is equal to 150, M is equal to 200. That means 200 ka half 100. But here P is 150, so P greater than half M. अरे रिलेशन समझ में आ गया कि नहीं आ गया? Why it is P
हाँ, sir.
greater than half M?
Yes, sir.
If you get P greater than half M means what does it mean? Simply, okay, you got the phenolphthalein alkalinity of the phenolphthalein end point is, let us assume that 150 you got. Let us assume. Then methyl orange alkalinity of the methyl orange end point, if you got 200, what is the relation between P and M? You calculate alkalinity up to phenolphthalein end point, alkalinity up to methyl orange end point. Then you compare these two values, these two strengths. Don't compare normality values. Calculate, compare the strengths. Then, if that whether that is P is equal to M, P is P greater than half M, or P is equal to half M, you calculate it. You do that. Then you can understand. Yes, if P greater than half M, what does it mean? See here, see how you have to logic, how you have to remember P greater than. That means with the help of phenolphthalein indicator, we are determining hydroxide and carbonate ions, half of the carbonate. So those ions are only present. You keep in your mind. So what is the strength? Here hydroxide is 2P minus M, carbonate is 2 into M minus P. That means let us assume that here P is 150, M is 200, so that is a P greater than half M. So 2P minus M, 2 into 150 minus 200. 300 minus 200, that is equal to 100. That is the hydroxide ion strength. अरे समझ में आ रहा है ना?
हाँ सर, आ रहा.
Yes, sir.
See, because see here, then carbonate ion 2 into M minus P. These are the experimentally proved results with the help of titration. They did the titrations. Then after that, whatever the results were obtained, those results were kept in this titration, summarized results. So this is the proved experimental results. So 2 into M minus P means 2 into M, M is 200 minus P. So 400 minus P, P is 150. So whatever the remaining value is carbonate ion. So that is the extent of the ion. That means here what you have to do at the end, what you have to write the conclusion. Yes, type of alkalinity is this caustic. Water is caustic alkaline in nature. That means caustic alkalinity means what type of ions are there? Hydroxide and carbonate ions are there. What is the extent of that hydroxide ion? The extent of that carbonate ion? You are calculating 2P minus M. You calculate it. Yes, P hydroxide ion strength is 100. Then carbonate ion strength is 250. Like that, you write down there. That means here, with the help of titration, we are determining what type of alkalinity, which ions are present in the water, then what is the strength of that particular ion. अरे समझ में आ रहा है कि नहीं आ रहा है?
Yes, sir.
Yes, sir.
Yes. If you are not understanding, please you ask. No problem. I will repeat it. Today also I am repeating. This is not at all new class. Okay. Then next one is P less than half M. P less than half M is nothing but what type of ions are there? See, P less than half M. That means M is more. M is more means carbonate and bicarbonate ions may present. Like this you remember. First P is equal to M. P is equal to 0. Only bicarbonate ions may present. P is equal to M. Hydroxide ions may present. P is equal to half M. Carbonate ions may present. That is the 2P. P greater than half M. P greater than, P is more. So hydroxide and carbonate ions are present. What is the strength of hydroxide? 2P minus M. What is the strength of carbonate? 2 into M minus P. Then similarly, P less than half M. M is more. So carbonate and bicarbonate ions may present. What is the carbonate? 2P. Bicarbonate, M minus 2P. So this is the summarized results. You have to calculate what type of alkaline. Then which ions are present in the water? What is the strength of that particular ions? Okay, simply here we are calculating. अरे getting my point? Alkalinity समझ में आ गया कि नहीं आ गया?
आगे
sir.
Yes, sir.
Array, once again I am saying, once again, quick revision. See, please concentrate, please concentrate. What is alkalinity? The capacity of water to neutralize the acid is called as alkalinity. Which ions are causing the alkalinity? Hydroxide, carbonate and bicarbonate ions are causing the alkalinity. Hydroxide and carbonate are the caustic alkalinity. Bicarbonate ions are the temporary alkalinity. Then with the help of, we are using two indicators, phenolphthalein and methyl orange indicators. We are using for the determination of alkalinity. So with the help of phenolphthalein indicator, we could able to determine the hydroxide and half of the carbonate ions. Then with the help of methyl orange indicator, we could able to determine the total alkalinity. That means hydroxide, carbonate and bicarbonate. Now, what is the procedure involved in this? Pipette of 20 ml of water sample, add 1 or 2 drops of phenolphthalein indicator, solution turns to pink red color, then continue the pink red color, then start the titration. When the solution turns to colorless, note down the end point, phenolphthalein end point. Then to the same solution, add 1 or 2 drops of methyl orange indicator, then continue from same reading. When the solution turns to yellow color to pinkish red color, reappears the pinkish red color, stop the titration, note down the end point of methyl orange indicator. This is one slot is completed. Then you go for second slot, you get the concurrent readings, then you go for calculation. First calculation is alkalinity up to phenolphthalein end point. Then N1V1 is equal to N2V2. Let us assume that N1V1 water sample, N2V2 is the acid sample. You have to calculate the normality of water sample, calculate the normality, then calculate the strength. Strength equals to normality of water sample into equivalent weight of calcium carbonate, that should be multiplied with 1000 in order to convert into ppm. Then you are getting the strength. That means alkalinity up to phenolphthalein end point. P is equals to strength. Let us assume that 100. Let us assume that. Then first calculation is over. Then second calculation, alkalinity up to methyl orange end point. Because you are getting the concordant reading of methyl orange, then calculate N3V3 is equal to N4V4. One is water sample, another one is acid sample. Acid sample, that strength was already given. Then calculate the normality of water sample, calculate the strength. Let us assume that you got 200. That is nothing but alkalinity of methyl orange end point. So that M you got. So first one, P is equal to 100, M is equal to 200. Let us assume that. Then you compare what is the relation between P and M. If P is equal to 100, then M is equal to 100 if you got. Then the relation between P and M is P is equal to M. If P is equal to 0, that means if the solution does not give any coloration with phenolphthalein indicator, that indicates that P is equal to 0. That means hydroxide carbonate ions are absent. That once again, what are the titration results? If P is equal to 0, bicarbonate ions are present. That means whatever the methyl orange strength you are getting, simply that is the extent of that particular ion. Bicarbonate ion strength is 100 ppm or 200 ppm. You write down that. The next one is if P is equal to M, that indicates that hydroxide ions alone may present in the water sample. What's the strength? So you substitute that strength. Then if P is equal to half M, carbonate ions may present in the water sample. So carbonate ions means that is 2P. 2 into if phenolphthalein strength, 2 into 100, 200. Or if P you got 150, so 150 into 2, 300, like this. Then P greater than half M. P greater than half M means what does it indicate? Hydroxide and carbonate ions are present. So 2 into M minus P, 2P minus M, those quantities. Then P less than half M, carbonate and bicarbonate ions may present. Carbonate is 2P, bicarbonate is M minus 2P. So you substitute those values, calculate it, you will be getting that. अरे समझ में आ गया कि नहीं आ गया alkalinity? If you are having any doubt?
Yes, sir.
Any doubt you can ask. Any doubt you can ask. No problem. Please ask. See here. See some. Here some. Some write-up was there. I am not reading at all write-up here. Here you read clinical class. What is this, man? Not required. You go through the slide. You can understand. See, these are the structures of methyl orange indicator. What is the in the basic solution? It is yellow in color. Then acidic solution it is red in color. The structures are there. Please practice these structures. Then after that, phenolphthalein indicator. So what is happening in the phenolphthalein indicator? Phenolphthalein acidic sample, it is colorless. So in presence of basic sample, see the forward reaction is in presence of basic, so hydroxide ion. So in presence of basic, what happen? The lactone ring is there. These are the cyclic lactones. The cyclic lactones are get cleaved and they are converted into quinoline structure. This is the benzenoid structure. That means benzene type structures are there. But here this is a quinoline structure. Why this is looking like a quinone? Here double bond quinone, and this is showing the pink color. Why it is showing the pink color? That due to extended conjugation. Why it is extended conjugation? Say for example that double bond, single bond, 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 double bond. That means entire the molecule conjugation is there. That means see where the conjugation is increased, those substances are showing the intense colors. So here the phenolphthalein indicator is showing dark pink color in presence of basic pH. Right? These type of concepts we can discuss so many. But due to lack of time or like that. Let's see. See here what are the color changes. See with the help of phenolphthalein indicator. Once initially the solution turns to pink color. So this is the pink color. Then you continue the titration. The solution turns to colorless. Stop the titration. Note down the reading. That is the phenolphthalein end point. Then you add methyl orange indicator. Due to addition of methyl orange indicator, the solution turns to light yellow color. That light yellow color solution titrated against standard acid. Continue the titration from same reading. Then the solution reappears the pinkish red color. This is the reddish pink or pinkish red or brick red color. Any color you can take. So when the solution turns to this color, stop the titration. Note down the readings in your observation table. What are those observation table? What are those readings? Here. Then after that, go for calculation. Then you would be getting alkalinity up to phenolphthalein end point strength, alkalinity up to methyl orange end point strength. Then what is the relation between P and M? So once you got the relation between P and M, then what type of alkaline what is the alkaline nature? You can identify. Then at the same time, what type of ions are there or which type of ions are there? That also you can identify. Then what is the strength of that particular ion also you can calculate. Say for example, P is equal to 0. That means bicarbonate ions may present. What is the strength of bicarbonate? So methyl orange end point, simply you put it there. Yes. और अभी समझ में आ गया कि नहीं आ गया?
Yes, sir.
Yes, sir.
Yes. See, intentionally I did revision of this alkalinity because there should not be any complication. In my class, all the topics should be thoroughly understood by all the students. That is my main motto. अरे समझ में आ गया कि नहीं आ गया? Alkalinity, do you have any doubt?
No, sir.
No, sir. It's clear.
So if you are having any doubt, please ask me. No problem, I will repeat it once again. Hardness determination and alkalinity determination आप लोगों को समझ में आ गया कि नहीं आ गया? Please, any doubt, even it may be small doubt, please ask. If you are having any doubt, please. No doubt?
No, sir.
No doubt.
Akka? I'm
Yes,
very
sir.
happy that, see, always remember. See, why I am repeating this topic, I could have moved to boiler troubles. But, see, the understanding is very, very important. Completion of syllabus is not a big deal. One day I can complete all the portion, all the 4 units. How? You can understand at the end. How could I able to complete all the 4 units? Within short span of time or otherwise even single class. I can complete the portion. It's not a big deal. But understanding is very, very important. See, always remember, while I am teaching, at which area or at which point the students may get confused. So that I am already knowing. So those points I am keeping in mind. I am repeating those points repeatedly so that there should not be any complication. Yes, this point students may not get. Yes, this point they may not understand. So I have to cover. So by keeping all the points in my mind, I'm taking the class. Does not mean that simply open the PPT and reading and completing. It's not my duty. Yes, समझ में आ गया है क्या अल्कलिनिटी?
हाँ सर आ गया.
Yes, sir.
Thoroughly understood?
Yes, sir.
Okay. Alright, tomorrow are you ready? Tomorrow,
Time, sir, please once again.
time around 8:30.
No, sir.
Okay sir.
ज़्यादा जल्दी
We
नहीं
will,
है, sir.
9 we will try, sir.
अरे
9
यार 9 man.
Sir, please,
Sir, 9.
9
9:30.
a.m. to 10 a.m. we can do.
9.
अरे okay 8:45. Please make it 8:45.
9:15.
Yes, sir.
Yes,
Okay.
sir. Yes, sir.
Okay sir.
Please, okay, be ready at 8:45. Please, okay. Tomorrow I'm going to complete at least. I would be slightly fast. Boiler troubles and at the same time, okay, softening of water. Then what is dual process? What is ion exchange method? What is lime soda process? Even I may cover something. I would like to complete this portion at the earliest. The technology of water. Okay, bye then.
Thank you sir.
Thank
Thank
you,
you
sir.
sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay, thank you everyone. Within short span of notice, almost 70% of students have attended. Okay, sorry for others because this is the time constraint was there. Or otherwise, I have to skip the class. That I don't want to skip the class. Okay.
Okay, sir. Okay, sir.
Okay. Thank you. Tomorrow 8:45. Please be ready. I would be sending the link at 8:30. Please keep your